Hey, good morning to another edition of the Weather Academy, and hopefully you enjoyed last Friday. We gave Craig the day off. He actually enjoyed a Friday off, and we'll be doing more weather history at the end of the week. Today we're going to tackle, and I give you kudos, because we're going to tackle something that no man or woman should ever tackle on TV. The battle or the discussion between the difference between relative humidity and dew point, one of the biggest areas of confusion that a lot of people have, and we're going to give it our best shot here.
Yeah, it's a complicated subject to discuss, and we had a couple of emails saying, hey, can you explain this? So you're going to have to kind of really pay attention on this one because it is very complicated, but we're going to give it our best shot. One of the most common questions we get as meteorologists, especially in the summer, is what is the relative humidity? Because people want to know, how humid is it? The problem is, what you're actually asking is, what is the dew point temperature? So we're going to discuss the differences between relative humidity versus dew point. And how we're going to start this off today is with a question. Now, don't stress out about this, okay? But we have a couple of examples here, and we would just want you to pick an answer, A or B, okay? What you're looking at here is two kind of virtual cylinders that are filled with water. Temperature of cylinder A is 55 degrees with a relative humidity of 100%. Cylinder B, notice the size difference, it's much larger. The temperature of that is 95 degrees with a relative humidity of 50%. So which example do you think is more humid? Just jot down your little answer on your paper there, A or B, and we'll circle back. And after we delve into this, we'll give you the answer.
Good question. Good question.
So that's where we'll start. Which example is more humid? Just pick one. Don't worry about it for right now. We'll break this down even more. So let's start off here, Tom. How humid does it feel?
How humid does it feel? And the key word here is, the feel of the humidity versus how saturated the air is. Now, the relative humidity, or we sometimes call it RH, it is not a good measurement of how humid it feels. Relative humidity tells you how saturated the air is, which may sound humid, but let's face it, if you have a sponge the size of a pencil and you fill it fully with water, it's saturated. There's not a lot of water in it, is there? Yeah. So where you get a big, huge sponge that you clean the car with, you fill it half full. It has more water than the little sponge, but it's not saturated. That's why relative humidity is not a good measurement. Dew point is the actual measurement of the amount of moisture in the air. I know that's hard because it's given as a temperature.
Yes.
And that's what can be confusing. But we have ways of giving you, which Craig will show in just a second, we have ways of letting you know how humid the air is based on the actual dew point temperature.
Yeah. And the key word here is when we talk relative humidity and dew point, especially in relative humidity, the key word is relative, okay? It's relative to the temperature of the air and the dew point. So we just kind of wanted to clear that little misnomer up. So while relative humidity is percentage, dew point is much, much more accurate. And when you're sweating, like little Franklin there.
Yep.
I'm going to call him Franklin.
That guy.
You're really, when you're wondering about the humidity, you're actually wondering about dew point temperature. So let's take a look at some examples here. So again, there are three containers, our three little cylinders, and notice the temperature difference and notice the size difference of each of these cylinders. So you have the kind of short, skinny one there with a temperature of 55.
Right.
And then we get a little bigger, and we expand a little bit more in the mid-range there with the cylinder in the middle, a temperature of 75. And then you have the big fat one on the end with a temperature of 95. So again, the thing to take away from this graphic here is the size difference, and note the temperature of each of those cylinders.
Exactly. And what it boils down to is the warmer the air, the greater its capacity to hold moisture. and we won't go into the full science or physics behind the whole thing, but the warm air can hold more moisture than colder air. So what Craig drew there is true. If he had another one that was 120 degrees, the cylinder would even be bigger. And if he had a 35-degree one, the cylinder would be smaller. So the cylinders there show that warmer air can hold more moisture.
Yeah, and if you think about it, warmer air expands.
Right.
So let's ratchet this up a notch here, Tom, and we'll talk about how relative humidity is a percentage of how much moisture is in the air.
Exactly. So what we have, what Craig drew here is he filled all 3 cylinders with 50%. Again, it's not water like in a pool. Think of it as water vapor. Okay,
right.
That's the vapor. We just put it as water so you can easily see it.
Right.
So notice 55, 75, 95%. All of them have a relative humidity of 50%. They're all basically, the atmosphere at that temperature is holding half of its capacity of total water vapor that it can hold. So they're all 50%, but which one has more water vapor itself?
Right. And I wanted to make a key qualifier here too. When we talk about, I really don't like the word hold. That's just my personal thing, because I know if my old college professor is watching, he's going to be over there going, Craig, the atmosphere doesn't hold anything.
Yeah.
But for our purposes, we will use that term. But the one qualifier I want to make here, and I've heard other meteorologists do it, and I might be guilty of it sometimes too, when we talk about dew point temperature, people will say it's the amount of water that's in the air. It's water vapor.
Right.
Water vapor.
First of all, yes.
Yeah. So we want it, that's a completely different state, okay? So if you hear that, that should, a light bulb should go off in your head. It's not the amount of water that's in the air when we talk about dew point, it's the amount of water vapor. And of course, water vapor, you can't see.
Right.
So
it's a gas.
Let's talk about dew point temperature. So we'll go back to our examples here with our 3 cylinders. So we have the temperature of 55, temperature of 75, and a temperature of 95. All of those relative humidities are halfway at 50%. So basically, the takeaway here is, how full is the container? How full is the container? So let's add in the dew point temperatures now. Dew point is an absolute measure of how much moisture is in the air, whereas relative humidity was a percentage. So again, going back to what I was saying earlier at the top of the show, when you're asking about humidity, you're actually asking about dew point, because that gives you an absolute measurement, an absolute number.
Exactly.
To gauge.
And the number happens to be in temperature form. So, for instance, you notice that the temperature at the small cylinder with the 55-degree temperature to be half full of water vapor, the dew point would be 37. If you go to the 75-degree one, in order to get it half full of its water vapor capacity, the dew point is 55. So what that tells you, because 55 is higher than 37, that means that there is more total water vapor in the 75-degree cylinder than the 55-degree cylinder, even though they both have the same relative humidity. And again, let's ratchet up here to use Craig's term. Okay, now we'll go to the 95-degree one. The dew point is 74. So that has more water vapor than the other two because its dew point is higher, even though the relative humidity is the same for all 3. The bigger cylinder, because it has more total water vapor, we know that because the dew point is higher. So that's what we mean when we say dew point is the absolute measure of how much moisture is in the air. The higher the dew point, the more water vapor is in the air, period.
All right, come back to us here on camera. Are you following along?
Got it?
Are you still there? Told you, this is a deep, dark subject. But we're actually going to visualize this a little bit more and talk a little bit more about the dew point. Tom was just mentioning The higher the number, the more uncomfortable it is. So we put together a little scale for you here, and we brought back our little guy Franklin.
There he is, Franklin.
So there's the dew point scale. Again, the absolute measurement, the absolute number. So here's kind of a scale for you. So if you get a dew point temperature below 55, it's dry air.
Right.
You know, and even lower than that, bone dry air. Typical of those Arctic outbreaks that we get in the winter. Dew points can be very low.
They can go down, sometimes even below zero dew point. That is super dry air, and that's why we tell you that. Actually, that's why many of you may have humidifiers, not dehumidifiers, but humidifiers on your furnace to add moisture to the air, because dry air, first, it's not good for your skin or your body. It's not good for your furniture. So we add a little humidity when it gets that cold.
Yeah.
Or that dry.
And then we go up the scale 55 to 60. That's pretty comfortable. It's pretty okay, 55 to 60. Once you get to a dew point of 60 degrees, that's when you start noticing it. That's when you start getting a little hot under the collar. Humid, 60 to 64. And then if you want to take the last three there, Tom.
There you go. Yeah, and exactly. You know, this is, we call this subjective. In other words, you know, sometimes some people don't mind 60, others are like, ugh, you know, but the general consensus scientifically is once you get to 65, we go from, gee, it's humid out there, man, is it muggy.
Muggy.
You know, we say
heavy
the air is thick. Yeah, we call it thick air, even though technically, and I don't want to put a monkey wrench here, but the more moisture in the air, actually, the less dense it is.
Yeah.
So technically, it's not thick, it's actually thinner. But I'm not going to go there because I don't want to confuse you anymore.
Right.
But I did want to mention that.
I'm sure a lot of people are already going,
don't do this to me. So yeah, muggy, and we will call it thick because it feels thick. And then once you get to 70, that's we basically, you know, it's very humid. We call that tropical. That's those are the dew points you get when you're in Miami, New Orleans, Houston. These are ones where dew points go from 70 to 75. And once you get above 75, it happens occasionally. I think the highest dew point I ever observed was 80.
Yeah, me too.
And that's just disgustingly high humidity. And
it's almost hard to breathe.
Yeah, I mean, I can only remember a handful of times here in Erie where we've been above 75.
Right.
But that's when it just gets very oppressive. And so it is. So the dew point scale measures from a meteorological standpoint. We need to know that because the more moisture is in the air, the more we look at flooding and severe weather potential.
Yeah.
For your standpoint, as the general public, it lets you know, well, what can we expect for the day?
Right. How's it going to feel?
How comfortable will we feel? Because the higher the dew, remember, we cool off by evaporation of sweat from our bodies. So when the dew point is high, the water can't evaporate as fast.
Right.
And it makes it harder for you to cool down.
Yeah. So I like to call it air you could wear.
Yeah.
When it gets over 70. It's just that muggy and buggy stuff.
Yes.
So that's kind of a breakdown of the scale. And actually, dew points are very important to forecasting, especially in the summertime, for our low temperatures. That's usually a pretty good indicator. The dew point in the afternoon, like mid-afternoon, 2, 3, 4, 5 o'clock, the dew point is usually where we're going to end up, or at least in that neighborhood.
Sure, absolutely.
For low temperatures. So just a little inside baseball for you. If you look at the dew point temperature in a midsummer afternoon, 2, 3, 4 o'clock, that's pretty good indicator where the low temperature will be for that night. And of course, as the temperature falls to dew point, we wet bulb, and then you get, when it falls to the dew point, you get fog. It can't. The temperature can't fall below the dew point. If it does, it regulates itself pretty quickly, and it's only by a couple degrees.
Yeah. So that's it. You know, and that's why the dew point is also an area where if you do manage to cool the air to the dew point, then you get your fog if it's at the surface. That's where the clouds form if it happens above the surface. And as we mentioned, it is probably the lower end of the lows. Kind of give you a bottom layer. So if the dew point is 62, then the low typically won't fall below that, but that might be your threshold for the low.
Yeah.
For the low for the night.
Yeah. All right, so let's go back to our question that we asked you at the top of the show. After all of that information we just threw at you, I don't know if it made it any more clear or not. Hopefully it did. Hopefully it did, but we wanted you to pick an answer. A or B. So which example would be more humid? Temperature of 55 degrees with a relative humidity of 100% in cylinder A.
Okay.
Oh, wait a minute.
Okay, we're going to,
This is cool.
Look, this is the C-130s are flying over Hammett. The reason they're doing that, and they're doing it right now, is for all of our first responders. They're flying over Hammett, but it's really for all first responders.
How cool.
They're flying over Akron, Cleveland, and also here in Erie. We just wanted to give you a quick shot of that. Obviously, it was quick. Thank you, Cindy, for pointing that out.
Way to be on the game.
Just a quick aside there. There you go.
And we'll raise a glass to all
Raise a glass. Thank you to all of our first responders and those in the
responders.
medical field for keeping us safe.
We were kind of hoping that would happen so we could show you that live.
And
here.
now we did.
How awesome is that? See, you get a little bit about humidity and relative humidity and a flyover.
And the current events.
How
yes.
cool is that?
All in the same place.
All right, so let's go back. Let's get back on topic here, but really cool shot, Cindy. Thank you. So again, which example will be more humid? Temperature 55 with a relative humidity 100% in cylinder A, or cylinder B with a temperature of 95 and only 50% relative humidity. Now, off the top of your head, you might think, well, that's easy, right?
Yeah.
100% relative humidity, it's got to be A. Well, if you chose B, you are correct.
That's right.
We'll give you a little golf clap. If you chose
Well
chose
done.
B.
Well done. Absolutely. And again, for the reason that we just talked about, the dew point is 55. The dew point is lower in cylinder A as opposed to cylinder B. And as we said,
Even though the relative humidity is 100%.
right, yeah. So cylinder B is more humid because the dew point is higher. But cylinder A is more saturated because the relative humidity is higher. So dew point tells you how much total moisture or water vapor is in the air. Relative humidity tells you how saturated that air is. So that's the big difference.
Yeah.
But saturation and comfort aren't always equal.
Right.
That's why we use dew point, because if the dew point's 74, everyone's going to feel it.
Right. Exactly.
Relative humidity of 100%, you're probably not going to feel it on most days,
it's not gonna
because
be too
most of
bad.
the time our air is saturated
And it's
in the
usually
wintertime.
raining.
And right, when it's raining, or in the wintertime, or cold air when it just can't hold as much. Forgive me, professor of Craig's old weather professor, but the holding of the moisture.
It's fine for this,
Yes,
for our purposes.
it
It's
is.
fine. It's fine. So a couple takeaways here. Again, size matters.
Yes.
So the bigger container is more capable and has more moisture in the air. Not water vapor. Okay. So if you chose B, congratulations. I think the big takeaway here, actually one more note about relative humidity.
Sure.
We do actually use relative humidities, especially in the springtime, for fire weather. If relative humidity is very low, that usually is prime optimal conditions for brush fires.
Sure.
So it does serve a valuable purpose. But what we wanted to do here is kind of dispel, when you ask us how humid it is, you're really asking us what's the dew point, not what the relative humidity is. So I hope that you kind of took that away. I know it's very confusing.
It is, yeah. So right, that's the bottom line. Relative humidity, fire weather, saturation, usually where clouds are and where fog is, that's where relative humidity shines. Dew point tells you how much total water's in the air. Severe weather
Vapor.
potential.
Water vapor.
Excuse me. How much water vapor's in it? Thank you, Professor. Okay. Well, I just got a C- now. And dew point tells you comfort, severe weather potential for a lot of flash flooding.
Yeah.
Because higher the dew point, the more water vapor, the more raindrops, the more rain.
There you go. Maybe we've inspired you to learn more about dew point and relative humidity. You can find it all out. Again, National Weather Service, a great source for education and information, and of course the Google machine. Just make sure you check your sources.
Absolutely.
All right? But remember, we want to hear from you. We're going to do this a couple more weeks here. Monday, Wednesdays, and Fridays. Weather at WJETTV.com. You can send us your weather questions and just keep chasing that inspiration, whatever you're interested in. The goal here, one of the biggest lessons I think that the reason why we're doing this is to take away whatever you're interested in is to learn as much as you can about it.
Absolutely. All right, that is our Weather Academy for this Monday, May 4th. Yes, May the 4th be with you. I went there. I'm a Star Wars fan. Yes.
What is it?
No,
or is
that's
that-
Star Trek.
Oh, jeez.
That's Star
I'm
Trek.
not- I'm
That's the
not-
Vulcan. Yeah, that's a different star. Good stuff, though. I'm a Trekkie.
See, I got a C- in that.
Had to do that, though, especially for those of you my age who remember both Star Trek and Star Wars. So that's it for now. Let's end it before we dig ourselves any deeper into this hole. Have yourselves a great day. For Craig Flint and I, thank you for joining the Weather Academy.
See ya.